Now let us move on to non-ferrous metal. Basically, non-ferrous metal are alloy which do not have any iron or ferrum inside it. For example, in this chapter, we shall only concentrate on aluminium, copper, magnesium, titanium, noble metals, and refractory metals. The properties of non-ferrous metal are such as good corrosion resistant, very much lower density and weight compared to ferrous metal, lower melting point, suitable for cold working processes as it usually have higher ductility and formability, higher thermal and electrical conductivities, and usually it comes in much more colors than ferrous metal. The first non-ferrous metal that we will explore and discuss are copper. So basically, copper is an alloy with reddish metal of bright luster color. The symbol are Cu and it has FCC crystal structures. Comparing to ferrous metal, it has lower melting temperature, approximately 1000 degrees Celsius. So there are a few types or grade of copper, which is pure copper, which contain 100% copper, brass, which is a combination of copper and zinc, bronze, combination of copper and tin, and also copper nickel and aluminium bronze alloy. The properties of copper alloy are it has high electrical and thermal conductivities, higher strength, good ductility, excellent corrosion resistance, which make it more expensive. And it is usually used as coil and pipes in wire application, especially in electrical, medical appliances because of its antibacterial properties, and also used as heat exchangers. Here are the pictures of copper. Let us take a look at the difference between brass and bronze. Brass is a copper alloy that are added with zinc, while bronze contain copper alloy that are added with tin. So the composition of brass is 60% copper and 40% zinc, while the composition of bronze are 88% copper and 12% tin. For brass, it is harder and stronger because of the addition of zinc and is more malleable and ductile. Therefore, brass usually develop high tensile strength while processing of cold working. In the properties of bronze, it is much more softer and weaker. It can resist higher corrosion, especially in seawater environment, and it is much more stronger and better corrosion resistant compared to brass. However, bronze usually are much more expensive than brass. The application of brass are such as electrical fitting, screw, and household fitting, while bronze are applied as spring, bearing, bushing, and some fittings. Other type of copper alloy are copper nickel and aluminium bronze. In copper nickel, copper are added with nickel, while in aluminium bronze, copper are added with nickel and aluminium. The composition of copper nickel are 90% copper or plus with 10% nickel or 60-40, and in aluminium, the composition are 82% copper, 6% nickel, and 12% aluminium. Copper nickel is also known as cupronickel, and it can resist high corrosion, especially in seawater environment. It also has good thermal conductivities and good ductility down to cryogenic temperature or a very low temperature. While aluminium bronze has higher resistance to corrosion and wear, high strength. It could also resist exposure of fatigue. It has fine gold color, and it is possible to do heat treatment in aluminium bronze, such as similar manner to steel. The application of copper nickel are in turbine blade, valve part, palm rod, and impeller, while aluminium bronze are used as heat exchanger, marine hardware, shaft, and pump. Now let us move on into aluminium and its alloy. So aluminium, it has silvery white appearances with the FCC crystal structures. There are a few types and grade of aluminium, which is represented in numerical form. It is 1100, 2011, 2024, 5052, and 6061. The most common one are 1100 and 6061. Aluminium has good electrical and thermal conductivities, which is basically second to copper, excellent malleability and ductility, and it is also high corrosion resistant to many environments, non-magnetic, non-toxic, and it is much more expensive than steel. However, it is difficult to weld. Aluminium are known as cooking utensil, especially as you can see, as an aluminium wrap, containers, and it could also be used as building material and automotive body parts. So here are the pictures of aluminium. Listed here are the aluminium and its alloy grade. For example, the most common one are 1100, which is actually pure aluminium, and it has excellent resistance to corrosion. However, it is very soft and ductile. Another one is 6061, which is the most versatile of heat-treatable aluminum alloy, and it has great range of mechanical properties, and it is used as structural application, board and furniture. Another type of alloy is magnesium alloy. Magnesium has silver white appearances with hexagonal closed-back structures. Shown here are the pictures of aluminium and its application. There are a few types of aluminium grade, which is Magnox, contain 99% magnesium and 1% aluminium. AZ91, which is combination of magnesium, aluminium and zinc, and AS41, which is combination of magnesium, aluminium and silicon. Magnesium has good corrosion resistance, especially in natural environment, and it is the lightest structural metal compared to any type of alloy. It has good ductility, poor strength and creep at high temperature, high fluidity and formability, especially when it is used in casting process, and usually magnesium is used to replace most engineering plastic because it has comparable density but higher strength. Example of magnesium application are aircraft component, missile application, chainsaw handle, laptop and computer casing. Here are examples of magnesium alloy grade. So as you can see, it is represented in alphabet and numerical representation. It is available in ASTM, Federal and AMS standard. Usually, magnesium alloy can be formed into sheet, plate, extruded bar, and forging stock. It is also can be used as extruded tube and also as pipe and section. Another type of alloy is titanium. It has metallic white appearances with hexagonal close-packed crystal structures. Titanium has higher melting point and boiling point. The boiling point of titanium is more than 3000. Titanium has a few grades available in the market. The usual one is CP4, which is grade 1 and pure titanium. It is the softest among all. CP3, or known as grade 2, has moderate strength, and CP1 is actually grade 4 with the strongest strength. There are a few more grades available, such as grade 5, which is combination of titanium, aluminum, and vanadium, and grade 6, which is combination of titanium, aluminum, and cyanide. Titanium has low strength as a pure alloy, but once you add with another type of alloy, it can extremely increase the strength of the metal. Titanium has excellent corrosion resistance as it is immune to air, marine, and many industrial environments. Because of this factor, titanium usually has higher costs because it has the ability to be used in difficult and the difficulty to extract the metal, especially to be used in extreme application. Titanium also has high chemical reactivity even at elevated temperature. The application of titanium, it is used as chemical plant component, surgical implant, marine and aircraft engine part for pure titanium, and steam turbine blade and rocket motor cases for titanium alloy. Here are the example of titanium alloy grade. For example, for CP4, it is used in automotive part as a medical, marine, and processing. And here are the standard ASME SB 363 up to 338, and the form available in the market are bar, flanges, fogging, sheet, and welding wires, while titanium grade 7 are used in chemical processing and power generation purposes, and the standard are ranging from ASME SB 363 to ASME SB 338. And the form available are usually the same as other grade, okay, but it is also available in wire form. Another type of metal is noble metal. It is actually alloy that can resist higher corrosion and oxidation even at elevated temperature. Types of noble metal are the first one, precious metal, which is argentum, or known as silver, and aurum, which is known as gold. And there are 6 platinum metal, which is platinum, palladium, iridium, rhodium, ruthenium, and osmium. So the properties of noble metal is they can resist corrosion and oxidation at higher temperature in most environments, such as most air and hot water. It also has high electrical conductivities and electron affinities, and even can resist chemical attack at higher temperature. Noble metal has high catalytic properties, that is why it is used as catalyst. The application of noble metal are usually it is used as coin and jewelry, and in antibacterial medical application, vehicle emission system, electronic, and fuel cell. Shown here are the properties and application of noble metal. For example, As you can see in the properties, most of them are corrosion and oxidation resistant, and it has high reflectivity, so mostly it can be used in jewelry. Another type of alloy is refractory metals. There are generally 5 types of refractory metal, which is niobium, molybdenum, tantalum, tungsten, and rhodium. So what is refractory metals? Refractory metals is a metal that can withstand higher temperature. Because the melting temperature of these refractory metals are more than 2000 degrees Celsius. It has high hardness at room temperature and is chemically inert. Usually, these materials has high density and weight, and it could also resist heat and wear. Refractory metals also can resist corrosion and creep, and also thermal shock, even though it is repeatedly heated and even though it is exposed to expansion, stress, and cracking. Refractory metals also has good electrical and heat conductive properties. It is used as tool in high temperature, wire filament, casting mold, and chemical reaction vessel, especially in corrosive environment. Here are the properties and application of each of the refractory metals. For example, niobium are immune to attack in most acidic environment, and it has wide variety of strength and elasticity. Molybdenum has high resistance to arc erosion. That is why it is usually used as a missile and rocket engine component. Tantalum has high corrosion resistance, and tungsten also has high melting temperature and density, which is why it is used in X-ray tube, anode, and target, and also lamp filament. And lastly, radium is used in catalytic for reforming platinum nuclear reactor semiconductors because of it has ductile to brittle transition temperature, and it also can resist most of the environment. So that is all, class, for the lesson in chapter 2.4, ferrous and non-ferrous. I hope you can grab some of the knowledge, and thank you so much for your attention. Thank you.